what is a linked list? Well, is linked list is a linear collection of data elements whose order is not given by their physical placement in memory. So what does that mean? First, let's just like visualize what a linked list is. So I'm gonna start off with the basics. So there's a singly linked list, singly, and singly linked list. I'm just put LL, and a doubly linked list. Okay, today we're just gonna worry about singly linked list though. That's what we're gonna worry about. So what does the data structure of a singly linked list look like? So first, usually we're gonna have a head. And hopefully if you're watching this video, you'll understand what pointers are. The head is a pointer, and it points to the node. Okay. The node consists of data and another pointer. We'll just call this P. And this pointer, what's another node? Again, I'm just gonna put D data, and also has a pointer. This pointer points to another node, D, P, and then it's gonna point, and the last one will always point to the end. Okay. So in reality, what the end is a null pointer. So this is what the data structure looks like. You can be like, well, it was pretty easy. Visualizing it's pretty easy. Yeah, it is pretty easy. But the thing is, what they mean by, let's pull up the definition again. A linear collection of data elements whose order is not given by their place in memory. Why? When we're making a linked list, we have no idea where this is. Where this is because of this. It's an arrow here. We have no idea where this is unless we have the data memory location because of this. We have no idea. We only know this location because of this. We only know this location because of this, because he's pointing to it, the head. Because in reality, when we think of arrays, right? Like say this is like an array, an integer array. We know that it's 4 bytes. You probably, well, now you know, probably, hopefully you know this. If you have 0, 1, 2, 3, we know if we do the array address plus 4, we'll get 1. If we do it plus 8, we'll get 2. Do plus, wait, 4, 8, 12, and we'll get 3. Yeah. So use a black, so there you go. Okay, but in here, it's very different. This could be, I'm just putting random addresses. This could be 0x33. In reality, it's probably not. This could be 0x like FF like E, something like that. And this could be like 0x5572 3, like some random hex address. So we have no idea where it is. Okay, let's code. Yeah, so this is like my fifth time. Like this is my fifth rerun of this. You probably don't care. But like let's code linked list. It was a weird cut, but like let's code it. So code dot is go again, right? So just start from scratch, include IOStream using namespace std and int main. Okay, okay, done. Not done, but let's go with this, right? So let's put paint, right? So let's use white. So we got head, right? Let's draw it again. We got D and P. Well, P points to like another one. D, P. Let's say this is the last one. This points to the end. When in reality, it's no pointer. So probably wondering like, what are these? Okay. So yeah, that's our first step on the agenda. Let's first make one of these. Those, I'm not sure if I already mentioned it, it's called a node. So let's make it easier on ourselves. Let's make a struct called node. So everything's public. And for this example, we're gonna like for the data, it's gonna be an integer. And then we're gonna have another one. Okay, let me not say it yet. Right? Let me not say the answer yet. So right now we have data, right? And we have another pointer. Okay. What will the pointer var type be? Think about that for a second. What will it be? It'll be a node. You probably knew that. I don't know why I asked, but yeah, it'll be a node of itself. Of itself might be the wrong word, but you get the idea. And we'll call it next. And uh just make it easier on ourselves because you'll probably see later why it's gonna be easier. We're gonna make it point to null pointer by default. Now let's see what we got. See, now we got that done, right? We made these two. We got these two done, right? So now let's make the whole data structure. Okay. So it'd be faster just do this. Okay. We're just gonna keep switching from both. So class linked list. Got P. And then in our private sector, we're gonna have something called a node and head, as stated earlier, right? So let me just like draw what we've done. Let's use a purple. We got head, right? So head is just there right now, right? So let's make constructor. Why not? So linked list, then head, because okay, so as earlier said, as said earlier, the last one will always point to null pointer. Okay. So just by default, when linked list default constructor is called, let's just make head equals null pointer, meaning that like there's no elements, right? As right now. So our next function will be void add. int x. Okay, x meaning like the, the number that the user wants to add to the linked list or us. But so right now, let's draw it again. Right now, head equals null pointer, right? So I'm just gonna draw a null pointer, be sad only right here. It's this null pointer, and head points to it, right? So now you're probably wondering, okay, how do we add a node to this linked list, right? So we have for that we have two cases, right? Let's go off to the side over here. Wait, oh, it's a huge drawing. Okay, it's gonna be little. So we have two cases. This is case one. Case, okay, it's a little pixelated. Case one, right? Head equals null pointer. Okay, let's visualize this real quick. So this is head, right? And it points to null pointer. This means that's empty, okay, because head points to null pointer. But here's case two. You probably have an idea of what case two is. The colon, right? Head does not equal null pointer. It points to like a node. This node points to like another node, we'll say, and then now it points to null pointer. But head doesn't point to it. Okay, head points to a node. That node points to another node. That node points to null pointer. Okay, head does not equal null pointer. That means that's not empty. Okay, okay. So let's code that. Okay, let's code case one first. So if head equals null pointer, we'll say this. We're gonna use dynamically allocated memory. Okay, I'm gonna say head equals new node. That's what the var type is, as you can see right here, right? New node. Then we're gonna say this head because it's a pointer. We're gonna say arrow, and then yeah, right there, data equals x. Oh, okay, good, right? So let's go back to our drawing. Why is it? It's a big picture. It's a big picture right now. So let's draw it. Let's pretend this is user, right? User just gave us a number, and it's a one. Let's be two. No, three. Yeah, three. Okay. User just gave a number and he put it through the add. So add three, right? So let's go through, right? Add three, right? X equals three right now. Let's say that. So it checks the first if statement. Head equals null pointer. Is that true? Well, let's check our drawing. Head does equal null pointer. Wow. Now we say head points to a new node. It's dynamically allocated, right? So let's erase this. Oh no, no, no. I'll do this in black. Yeah, there you go. Do that, right? And then purple points to a new node. You're not right. And because, as we said earlier, right, it like next points to null pointer, so it like points to null pointer by default. Okay. Then let's look at our next line of code. Head data equals x. So let's go here. X, right? Pretty much x there. So now data equals three. Boom. We're done. We just added that to the linked list. Okay. Here comes the tricky part though. Right? Here comes the tricky part. Else statement. Oh, let me put case one, right? Now this is case two. Because there's only two options. Does head point to null pointer? No, okay, it points to something else. So case two. Okay. Let's think about case two. Let's think about it. Let's think about it. Right. So case two, that means head points to a node. Okay. But that doesn't necessarily mean okay, for this example, right? Next node points to null pointer. We know that. But for future, we have no idea, unless we have a count or something, of where the last node is. Okay. So that's why we're gonna do like something cool. Okay. Let's use this example. Say a head for H points to a node, points to a node, points to a let's do here, points to a node, points to another node, and points to null pointer. Okay. Let's put that on low. I hate how that's like just there. There you go. So you're probably thinking, okay, well I can just move head and keep going till it's like to know that points to null pointer. Okay, let's do that. If you're thinking that, if you're thinking that, okay, let's go with whoever was thinking that's idea. Okay, okay. So head. Okay, hold on. Head points to here. Okay, originally, right? Then we're gonna make head point to whoever's pointing here. Whoever this node's point to. Okay, now it points here. Okay, let's point here because this one doesn't point to null pointer. It points to node. So now we point here. Oh, okay. This one doesn't point to null pointer either. Let's go to where it went. Okay. Oh shoot, we found it. We found the one that points to null pointer. Okay, then we can just do what we did right here, right? Head new node, right? Head data equals x, right? And let's do that. So like if we did that, so let's put this dude away. Uh, shoot, sorry. There you go. Right. If we set that, shoot, null pointer. Okay, then we made a new node, right? New node. Then we put that data. We'll just call it d again, right? And then done. Okay, let's say user wants to put a new one. Okay, actually no, scratch that. Let's say we want to view the linked list. Okay, let's see. Uh-oh. Wait, how do I go back to the start? You can't. You just lost the start of it. remember from like the start of the video, we said like we have no idea where these addresses are other than like these pointers right here. We lost it. There's no way we can go back. So whoever thought of the idea of moving ahead, you were wrong. Okay. So let's do it the right way. Okay. So let's undo all the way back here. There you go. So now we here. Okay. So what we want to do, I don't know what the official word is, but I like to call it the goer. Okay. We're gonna have called something the goer. So let's call it G for short, and then previous. Okay. So to start this, we're gonna make goer point to where head is pointed. So goer points here, and we're gonna make P point to whatever is previous. As of right now, there's nothing previous, right? So then goer points to wherever this node is pointed. So goer points to here, and previous points to wherever is previous. Okay. We're gonna keep going till goer equals null pointer. So I'm just gonna do next iteration goer equals this now, right? But then previous equals this one. Okay. Next one. Well, you get the gist of it, right? Then all of a sudden goer will equal this, and previous will that, and that. Let's go to the end case, right? Not the end case, but the end result, right? Goer will point to this, and then previous. Sorry for like a really bad drawing, but like previous, now point to this. Boom. Now we can say previous. Then we can say this. Then we can say P next equals new node. Instead of having the head, I mean, go through the whole thing. In reality, we never want head to move. Okay, we never want head to point to somewhere else. Only the start of it. Okay, only the start of it. So now using this method, there's probably a different method, but I really like this method. He will point to the last one, right? While goer will point to null pointer. Boom, simple, right? Hopefully. So now it's coded. So else, this is the else case, right? So like I said, let's make a goer, oh no, node, pointer goer, right, equals head. And we're gonna make another one called prev. That's what's called previous, right? Equals it'll equal nothing right now. Okay. So what loop would we use if we have no idea how far this linked list goes? A while loop. Hopefully you said that. A while loop. So while goer, right? What's the end goal? What's the end goal? Let's go back. While goer does not equal null pointer. Okay. So while goer does not equal null pointer, we're gonna say, uh, so again, let's shoot. Okay, we'll go to new space because that's looking like kind of bad right now. So head, let's do a small sample size, just like 2 nodes, and null. So again, goer equals this, then P equals nothing right now. So we're gonna make. So actually, let's think about it real quick. What do you think we should? What do you think we should do first? I have no idea what your answer is. But what do you think? Okay, think about it for a second. So first, let's say you thought that okay, let's make goer equal a goer point to wherever this node's pointing to. Okay, yeah, let's do that. Okay, now previous points to what? Now you can say oh head, right? Okay, let's do that. Okay, fine. Now, actually no, let's say head didn't exist. Let's say it was a node, right? Actually, scratch that. Okay, you're wrong. Whoever said goer first, you're wrong. Okay, first you would make previous. This is the right answer. First you make previous point to goer, wherever goer is pointing to. So p equal goer, and then previous equals goer. Okay, then you make goer equals to wherever this node's pointing to. So goer equals this now. Shoot. Okay, don't mind that. Now, okay, let's do that again. So goer now points. No, okay, hold on. Previous equals to wherever goer points to. Actually, I just put do not disturb on Discord real quick. So now let's say so previous equals goer. Okay, because goer does not equal null pointer yet. Okay, so previous now points to here. Then we're gonna say goer points to wherever this node points to. So boom. Okay, now equals null pointer. Now we can say the p next equals new node. Okay, so that's what we're gonna do. So while goer does not equal null pointer first, let's make previous. Okay, previous equal goer. Okay, then we say goer equals goer next. That is it. That's all we need to put in the while loop. Okay, because it will stop when goer equals null pointer. So now, pretty much the same thing as here, except we change head previous. I would say previous equals ooh. Okay, hold on. Previous next. Okay, not the same. My bad. Previous next, because let's visualize this. Not previous itself. Okay, previous the nodes next. Okay, not previous the node previous nodes next. Okay, so next equals new node. Okay, then we say I don't know what do we say. Let's think about it. What should we say next? Think about it for a second. Pause the video if you want. I could have said that earlier. Pause the video if you want. But let's think about it. Think about it. Oh, okay, we're done thinking. We're gonna say this previous. Next, we're gonna say data. Because that points to a node right now, right? So now equal, oh shoot. That equals X, what the user gave us. Okay. Now let's code that. Let's go back to our original drawing. Hopefully you remembered it. Probably didn't, because there's like a Really, really bad drawings. So let's go through it. Let's actually this looks really bad, but this is like possibly the best way I could do this. Let's go. Okay, say okay. Hold on. Let's say this dude gave us a different number now. He wants to add wow, look at this. Easy. 13, right? So let's go through the void add function real quick. Let's save it so it doesn't like do anything weird. So does head equal no pointer? Nope, it equals a node. Okay. So it goes to else case. So goer, let's make it goer. Goer equals head. Previous equals it doesn't equal anything right now. Not sure what it, I think it points to null pointer by default, but don't quote me on that. Okay. So while goer does not equal null pointer, okay, doesn't equal null pointer right now. Previous equals goer. Okay. Now goer equals goer next. I swear there's someone in my house. I swear I'm hearing things. So goer equals goer next. So goer next, which is what? Null pointer. Aw, points to null pointer. Null pointer. Oh, I'll put another sad face. Okay. Now goes back to the while statement. Well, goer does not equal null pointer. Well, it does. So it breaks out. Okay, now we say this. Previous. Okay, previous points. Okay, now we're talking about next. So next. Okay, talking about this one right here. Equals new node. Okay. So let's erase this because it doesn't. I'll make it bigger. Doesn't. Oh shoot. Didn't want to do that one though. Doesn't point to null pointer now, right? Because it points to a new node. So it points to no node. The node points to null pointer by default, right? Because we made it like that. And then we say previous. Okay. Next. Okay. What? Data. Okay. This one equals x. Equals 13. Boom. Done. Okay. We've just made the two cases, the two only cases, hopefully, thinking about it right now, I don't think, for like adding it to the end. Okay. And yeah, that's it for the add function. Right? There's multiple things you can do. Let's just implement like a view function real quick. Then I forgot nothing. Hold on. We're gonna have two more functions. We're gonna have you call it like a void like view like uh items like data. We're gonna have like that, and then we're gonna have deconstructor. Okay, this is very important, right? Because we don't want to have memory leaks. Okay, memory leaks are bad. We don't want that. Okay, let's make a view data real quick. Same concept here. Okay, let's make this full screen. We do not want to move head at all. We don't want to move it. We want something else that points to the same thing as head, and then that goes through the whole thing. Okay, so let's do that. Let's can I can't zoom in. This is how it's gonna be. Looks like. So again, so while actually hold on. We're gonna make another goer. Okay, I'm just gonna copy this. So while goer does not equal null pointer, we're gonna say let's be cool about this. So let's put some like see out the list of items of yeah, let's put it like that. And then we're gonna say see out to underscore string. So I'm doing that now, I guess. Goer data. And then uh yeah, we'll put that up. Then that's it. That goes through the whole okay, hold on. Yeah, that goes through the whole list and just prints all our data. Obviously not like there's probably like better formatting I could have done instead of just saying a number. But that's just pretty much the same concept. That's pretty much the concept. Okay. Now we gotta talk about deconstructor. Okay. Now this is the part where you want to move the head. Okay. Let's erase this. Pause the video, you can screenshot. I don't I'm just gonna, you know what, no. Just go back, rewind. Rewind. Okay. So let's do green. Okay. So head points to this node, right? And it points to this node, points to this node, right? And points to null pointer. Now for deconstructor, this is where we want to break the rules. This is where we want to say, head, you're gonna move this time. You're gonna go through all the nodes. Okay. So this is what it's gonna look like. We're gonna say, I'm gonna visualize it, and we're gonna code it. Okay, we're gonna have another goer. Yeah, let's call it goer. So goer equals head. Let me think about it real quick. Equals head next. Okay, equals head next. Okay, it equals to whatever heads nodes next points to. That sounds a little weird, but it points to whatever heads nodes next points to. So it points to this. Okay, then we're gonna say delete head. So this is gone, but in reality it's still there if you know what I mean. Then we're gonna say head equals goer. So now head points to this. Again, we're gonna say goer equals heads next. Yeah, heads next. So now it points in reality to here. Then we're gonna say delete head. Okay. Now head equals goer. Okay. Then we're gonna say goer equals heads next. So now it points to well null pointer. Then we're gonna say delete head. Okay. Then we're gonna say head equals goer. Boom. Now head equals null pointer. Now we're done. So if head equals null pointer, we stop. That's our end condition. So using that as our head condition, as our end condition, let's do it. So while head is not equal to null pointer, right? We're gonna say what was it? Oh yeah, node goer equals head next. Then we say delete head. Ooh, right. Then now we say what do we say? What was it? Nah, just joking with you. We say head equals goer right there. Boom. Right. And that's it. That's it. We're just clearing a whole linked list. That's it. Okay. So let's make a main. Why not? Right. Let's not. Let's hope. I'm hoping this is all right. I think this is all right. Okay. This looks right. So linked list. Pause it real quick. So I just took a. It was like a little. It's a little like. Just added like all the numbers from 0 to 9. Okay. This is my first time reacting to it. I have no idea if it works. Let's save it. Right. Terminal. G plus plus hello.cpp. Hello.cpp. It piles. Wait. Found it. Found it. Okay. So I'm bad. What do you guys say? Goer equals goer. Next. Oh my god. Next. There you go. No, 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 no. Next. There you go. Okay, now let's clear it. I didn't save. Oh my god. There you go. Okay. There you go. The list of items. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, let's check if let's check if Valgrind work. Let's see what Valgrind got to say about it though. Valgrind's like to find out if you have memory leaks. Boom, no leaks are possible. Done. There you go. Boom. You just learned how to make a linked list. Only using one way of it though, adding to the end. There's multiple ways of doing this, right? And yeah, that's it. Thank